Hello and welcome to Solved Papers channel. My name is Godfrey. In this video, I'm solving a Cambridge IGCSE chemistry topical question on electricity and chemistry. This is a June exam series of 2019. I prefer topical questions when it comes to revision and preparation for exam. I find revision topic-wise very effective, and I encourage you to read your notes and your textbook on electricity and chemistry, and then join me in solving these questions that were set on June 2019. These are structured questions, and you will find it easy when the knowledge is still fresh in your mind concerning this topic of electricity and chemistry. If you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new video. Let's get started solving these questions. Question number 1, of course, you'll have this to help you know from which variant and which question it appeared. This is variant 4.2, and this was question number 7 in that paper, if you need to refer, and also to check your marking scheme if you saw a desire. So let's get started with this question. Number 1A, displacement reactions occur between metals and metal ions. Metals and metal ions is a displacement reaction. Displacement reaction can be used to determine the order of reactivity of metals such as lead, nickel, and silver. The Ionic equation for displacement reaction is shown. Nickel in solid form reacting with lead ions to give us lead solid and nickel ions. Basically, nickel displaces the lead from a solution. The Ionic equations for these reactions are shown. Of course, lead loses 2 electrons, which are gained by lead to be ejected out of the solution. The Ionic half equation, show that electrons are donated by nickel atom and are accepted by lead. Identify the reducing agent in the displacement reaction. Give a reason for your answer. Of course, reducing agent donates electrons, and oxidizing agents gains electrons. Therefore, in this case, the reducing agent is nickel. Nickel is the reducing agent, and the reason is nickel has donated electrons. Donates electrons to lead ion. So nickel is the reducing agent. Okay. What is the general term given to the type of reaction in which electrons are transferred from one species to the other? The general term that we use is redox. Redox to mean reduction and oxidation. When electrons are transferred from one species, the species that loses electrons undergoes oxidation, and that is the reducing agent, and the species that gains the electrons undergoes a reduction, and that is the oxidizing agent. The Ionic equation for another displacement reaction is shown. The Ionic equation, lead and silver. Of course, lead is more reactive than silver, so it displaces silver from the solution. Write the half equations for this reaction. Of course, we have lead, which is solid. This one will give electrons to get into solution, plus 2 electrons, and silver in solution will gain the 2 electrons. So you need, silver's got a oxidation state of 1, so it will gain the 2 electrons. So you need 2 silver ions there to gain the 2 electrons to give us 2 atoms of silver. Solid. This is aqueous. So that's the half equations for this reaction. Okay. Part C. Use the information in A and B to put the 3 metals lead, nickel, silver in order of reactivity. Nickel is more reactive than lead because it has displaced lead from a solution, and lead is more reactive than silver. Of course, you can have a look at the equations here. Lead displaced nickel from solution, so lead is more reactive. And then here, lead is displacing silver from a solution, so lead is more reactive than silver. And that is what we write here. So nickel is more reactive. The most reactive here is nickel, and the least reactive is silver. So lead is right in between here, and then silver is least. Okay. Part D. Nickel is a transition metal. Nickel is a transition metal. Nickel is stronger than sodium. Describe 2 other differences in physical properties of nickel and sodium. Of course, transition metals have got higher densities than group 1 metals where sodium is located. So nickel has high density, has got a higher density than sodium. Then the other is transition metals have got a higher boiling point than group 1, so nickel has higher melting point than sodium. Those are 2 physical properties. You can also say nickel is a better conductor of electricity than sodium. That's another physical property. Part E. Predict one difference in the appearance of aqueous solutions of nickel compounds compared to aqueous solution of sodium compound. One difference. Transition metals forms compounds that are colored, and therefore nickel compounds are colored while sodium compounds are colorless. So solutions, because these are aqueous solutions, solutions of nickel compounds, solutions of nickel compounds, solutions of nickel compounds are colored, while sodium compounds are colorless. That's the difference. Part F. Copper is refined purified, of course, by electrolysis. Nickel can be refined using a similar method. Diagram shows the refining of nickel by electrolysis. Complete the labels in the boxes. We have the power supply here. We have the positive electrode, and therefore this is where we'll have the impure nickel. And on the cathode, This is where we have pure nickel. Electrolyte will be nickel nitrate or any solution of nickel. You can go for nickel nitrate. We know all nitrate salts are soluble, so that is easy to figure out. Nickel nitrate right there. Indicate by writing N on the diagram where nickel is produced, right? Well, where nickel is produced. So I'll write N here. Nickel is going to be produced on the cathode. Transfer from impure to pure, which is the cathode right there. Okay. It's great you're watching this electricity and chemistry video. Remember, practice working out these questions is key for you to learn what we are doing here. You may get this same paper I'm solving right now from this site here, softpapers.co.uk. The site I'm talking about is this one here. This is softpapers.co.uk. You can head there and of course go to IGCSE Chemistry 2019. You've got other papers for other years. Chemistry 2019, you'll get this paper here. So we are doing Chemistry 2019 topicals. We have for November both multiple and structured. Some solved ones here to show you how that is done. We are doing June. The paper that we are dealing with is electricity and chemistry right here. And so I'll need you to go there and click this. Click this green button here. Click here, get all solved topical in a zip folder. Of course, when you click there, you will come right here. And here you will find papers for both 2019 topicals, 2018, 2017, 2016. And of course, you can get as many as you need. I'll require you to ask your parents to help you with this one. Of course, 2019 November, 2019 both multiple and structured. 2019 June, both multiple and structured. And therefore, it's fairly priced, just £9. That's fairly cheap, and you'll get papers that will help you. I guarantee you will be prepared to get your A star. That being said, let's go to question number 2. Question number 2. Solutions of ionic compounds can be broken down by electrolysis. Okay, we know that. Electrolysis is breaking down of ionic compound by passage of electricity. That is something that is clear to all of us, or majority of us who have done good revision. Concentrated aqueous copper chloride, concentrated, we are told, was electrolyzed using apparatus shown. Okay, we have power supply, we have electrodes right here. Cathode is made of platinum, same as anode. Then right here we have the concentrated copper 2 chloride solution. The ionic half equations of the reactions of the electrodes are shown. At the negative electrode, copper ions will be discharged by receiving 2 electrons. At the anode, at the positive electrode, chloride ions will chlorine will be discharged when chloride ions are released to electrons right there. Platinum is a solid, which is a good conductor of electricity. States other property of platinum which makes it a suitable use as an electrode. We know that platinum resists reactivity, so we usually say platinum is inert. Platinum is inert. It does not react, does not react with chlorine, does not. Remember, chlorine is a very reactive gas, does not react with the chlorine that is produced in the anode. With chlorine, we put it chlorine gas formed at the anode. Alright, part 2. State what would be seen at the positive electrode during electrolysis. Of course, since a chlorine gas is formed at the electrode and the anode, which is the positive electrode, we will see bubbles of a green yellowish gas, yellow gas. Chlorine is a green yellow gas, so we'll see bubbles of green yellow gas forming at the anode. You are told to state what will be seen. What will you see? Of course, the gas will be yellow because chlorine is a yellow gas. Part 3. State and explain. 2 questions there. State and explain what happens to the mass of the negative electrode during this electrolysis. Remember, we are purifying nickel. We are purifying, this is basically not remembering question number 1. The negative electrode is still platinum, and we are seeing copper is being discharged at the platinum. So copper will coat around the platinum, and the mass of a platinum will increase. The mass of the platinum electrode, which is the cathode, will increase. So states what would happen to the mass of the negative electrode. The mass of the cathode will increase. Mass of cathode increases because copper is being discharged there, so it will form a coating on that electrode. Why are we? What is the explanation behind here? Copper ions are removed from the solution. And deposited on the cathode. So the mass of the cathode will increase. Part 4. The concentration of aqueous copper 2 chloride electrode is that is, the concentrated aqueous copper 2 chloride electrode is green. Suggest what would happen to the color of the electrolyte during the electrolysis. Explain your answer. Suggest the green color fades away. The green color of copper 2 chloride will fades away. Of course, the explanation behind that is that we are removing the copper ions which are responsible for the green color. The copper ions are responsible for the green color are being removed from the solution. So this will decrease the green color, be removed from the solution. Part 5. Identify the species that is oxidized during this electrolysis. Explain your answer. The species that is being oxidized, of course, remember that oxidation is the loss of electrons. Oxidation is loss of electrons. Remember that. Oxidation is electron loss. And in this reaction here, you can see chloride ions are the ones that are losing electrons to form chlorine. Copper ions are gaining electrons. So chloride ions are the ones that are be oxidized in this reaction. So the species that is oxidized is the chloride ions. The explanation is, of course, oxidation is the loss of electrons. Oxidation is loss of electrons. Loss of electrons. And the chloride ions are losing electrons. Chloride ions have lost electrons. Have lost electrons. Of course, chloride ions will lose electrons to form chlorine plus an electron. But of course, you need two of these to form a molecule of chlorine, and therefore to lose 2 electrons. So they have lost electrons. Part B. Metal objects can be electroplated using silver. Metal object can be electroplated using silver. Of course, the reason for electroplating, one is to improve the appearance of the metal object, and secondly, if the metal object is made of rust, to prevent rusting. Electroplating does that. Describe how a metal spoon can be electroplated using silver. Describe. Include in your description what to use as the positive electrode and as the negative electrode, what to use as electrolyte, and you write the Ionic equations to show the formation of silver. You may include a diagram in your drawing. Of course, I will love to do that. This is my diagram here. Okay, and I have my electrode there, and my other electrode right here. I have my electrolyte. This is my electrolyte right there. And I'm connecting this one to the positive terminal of the cell. The negative terminal is connected to this one. And of course, that makes this one to be the anode. This is the cathode. And the solution, the electrolyte, here is going to be silver nitrate. Remember, we are coating with silver, we are electroplating with silver. So the electrolyte should be of silver, so that the silver gets discharged. And we are electroplating a metal spoon. Sorry, this is a metal spoon here. So let me draw the spoon. Draw a spoon. That is a spoon. The electrolyte is that. This is the spoon connected to the negative terminal, and this is pure silver. Right there. So the spoon is the cathode, as you can see. Spoon is on the cathode, or is the cathode. Okay. And then the pure silver metal is the anode. remember, you will be told in your description, include what to use as the positive electrode at the anode and what to use as the negative electrode. We have electroplated the spoon with silver. So pure silver metal is the anode, the spoon is the cathode. We have done that. And then also you're taught to use what to use as an electrolyte. The electrolyte is silver nitrate. Electrolyte is silver nitrate solution. Half equation of formation of silver. Of course, silver will gain an electron and be discharged as silver atom. Of course, this is solid and this is aqueous. That is the half equation. Of course, the other half equation is that the coating will happen on the silver spoon, right there. Okay. Give one reason why metal spoons are electroplated with silver. Oh, I said this earlier on. Of course, to improve appearance. Silver is attractive, is grayish in color and shiny. Therefore, the appearance of silver is good, and also to prevent corrosion. To prevent corrosion. Those are the two. Those are two. You only needed to give one. Okay, this is appearance. All right. Question number 3. Let me welcome you to, before we get to question number 3, I'd like to welcome you to my online tuition classes. I do tuition classes online. We have a site we call spacademy.co.uk. You can check us there. I can show you the site here. SP Academy. SPE basically means Soft Papers Academy. You'll find us here. Of course, we have ICT, mathematics, physics, and biology. You can explore our site, take time and explore our site, but I need you to check out the student guide. We give a step-by-step guide on the student dashboard. You could also find time to check out this video to get familiar with our online live classes. For you to join me in my online classes, I need you first to register. Registration is free. You need to register, state your as a group, a student. Of course, you go for a student, you select a student, then you give us your details. You give us a correct email, because we'll send an email to you in order for you to activate your account that you're going to create. Once the account is activated, you'll be able to sign in and find a tutor and book a lesson with us. I will be glad to help you get your ESTA in chemistry and in physics, whichever you desire. So I'm looking forward to having you, and I guarantee you will discover a great opportunity to get outstanding grades. So see you in my tuition class. I'd love to help you. Of course, my charges is one student. If you want one-on-one, I'll charge you £35 per hour. But if you are 4 or more students, I will give you a fair price of £25 per hour. Fair price, comparing to what others are charging, 70, even £100 per hour. So come along and let's do chemistry together in my online class. See you. Question number 3. This question is about chromium and chromium compounds. Chromium is a transition metal. transition element suggests why chromium is manufactured by electrolysis and not by reduction of chromium 4 oxide, chromium 6 oxide with carbon. The reason why chromium is not manufactured by reduction, but is manufactured by electrolysis, is because chromium is a reactive metal and cannot be reduced by carbon. So chromium is a reactive metal which cannot be reduced by carbon. So the only way to manufacture chromium is by electrolysis. Suggest the products of the electrolysis of molten chromium chloride. Of course, the ions present for molten chromium oxide will be chromium, and oxygen. Okay, chromium is, I think, is +3, and oxygen, right? So you'll find that at the anode, oxygen will be discharged. The oxide ions will go to the anode, and then it will be discharged as oxygen. And the cathode, at the cathode, chromium will be discharged. So the positive electrode, which is the anode, will have oxygen be discharged. Suggest products of electrolysis will be oxygen gas. And then the negative electrode, here the chromium metal will be discharged. Chromium will be discharged right there. Right. Part B. Chromium can be manufactured by reduction. Chromium can also be manufactured by reduction of chromium 3 oxide, right, with aluminium. Chromium 3 oxide with aluminium. And of course, I need to correct here. This is chromium 6. It's got a valence of 6. So this is chromium 3 here. This is chromium 3 with aluminium. So how does this equation show that chromium oxide is reduced? So we have this equation here. So what is reduction? Reduction is loss of oxygen. Just like oxidation is gain of oxygen. So you can see from this reaction, chromium 3 oxide has been, the oxygen with chromium 3 oxide has been snatched by aluminium, and it has been reduced to chromium, while aluminium has been oxidized to aluminium oxide. And therefore, how does this equation show that chromium is reduced? Chromium 3 oxide loses oxygen, and reduced to chromium metal. So it has undergone a reduction right there. Sorry. Okay. The energy level diagram for this reaction is as shown. Of course, we have the reactants there, we have the products there. the progress of reaction, and then the energy. So the products are at a lower energy compared to the reactants. And therefore, when the reactants have got greater energy compared to the products, then the reaction is usually exothermic. The reaction is endothermic if the products have got more. These are reactants, and these are products. If the products have got more energy than the reactants, then this is an endothermic reaction. But when the products have lower energy compared to reactants, then this is an exothermic reaction. So explain how this diagram shows the reaction is exothermic. You say that the reactants have greater energy, or have got more energy than greater energy compared to the products. So the difference in energy has been lost as heat to the surrounding, and that's why the reaction is exothermic. Endothermic reaction absorbs heat from the environment. Part C, chromium is a transition element. We had mentioned that earlier on. Sodium is an element in group 1 of the periodic table. Describe 2 ways in which the properties of chromium differ from those of sodium. Okay, one is the melting point. Chromium has high melting point than sodium. Okay, the second is that chromium forms colored compounds. Chromium forms colored compounds. Of course, sodium's compounds are colorless. Sodium compounds are colorless. Right. Chromium is silver-coated metal. Chromium is silver-coated metal. The diagram shows a copper spoon. The diagram shows how a copper spoon can be electroplated with chromium. Right. Remember, we be told chromium is a silver-colored metal. It has got a good appearance. On the diagram, label the cathode and the electrolyte. This is the electrolyte. And the cathode, where the chromium will be discharged, will be the spoon. This is the cathode. Okay, remember, chromium will be discharged at the cathode. Assuming this is chromium 3, will receive 3 electrons and then be discharged as metal. Then it will coat the spoon right there. Give one observation that is made during the electroplating process. Spoon becomes silvery. Of course, when this chromium is discharged on the cathode, it will coat the spoon, and it will the spoon will become silvery. So spoon becomes silvery in color. Suggest one reason why metal objects are electroplated. Of course, to improve their appearance. That is one. And also to prevent corrosion. To prevent corrosion. If the metal that makes the spoon is corrosive, like if it is silver or if it is iron, those will undergo corrosion. You don't want to take food with a corroded spoon. That will not be healthy. So electroplating makes metal objects more resistant to corrosion. Corrosion is basically wearing out or undergoing rusting. Lastly, part E, nichrome is an alloy of nickel, iron, and chromium. Nichrome. Which one of these diagrams, JKLM, JKLOM, best represents nichrome? An alloy is a mixture. Alloy is a mixture. Okay, of here it is of nickel, iron, and chromium. You melt nickel, you melt iron, you melt chromium, and then you mix them up. Therefore, when you mix them up, the structure will be like the structure in K. Okay, you can see the structure in J is having the three different atoms, 1, 2, 3, 4, but the atoms are arranged in a regular pattern. That is not the case with alloys. A mixture, you don't order the way the atoms of different metals, like here in this case nickel, iron, and chromium. When you melt all these three metals and mix them, there's no way to determine a regular pattern like this one. This is regular pattern. Okay, a regular pattern is not possible, and therefore I will go for K. K will be the one which represents nichrome, which is an alloy. Okay, the arrangement of it has got three particles. The this one, and the white one. Okay, the white circles. Those are three particles representing nickel, iron, and nichrome, and they are arranged in a way that is not regular. Okay, you can see here all the gray ones are on one line, all the white ones are on one line, the black ones are on one. That is regular arrangement. That is not possible. For L has got only two types of atoms, black and white. So it means that these are two metals, but nichrome is three metals, nickel, iron, and magnesium. So L is out. And then also this is one, M is also regular. You can see the atoms of different metals are arranged along one particular line. So this is also not correct. So we are told to which one of these best represents nichrome. So this will be K. Particles arranged randomly. Particles arranged randomly. Therefore, nichrome, which is a mixture of three atoms, and nichrome is a mixture of three. Is a mixture of three metals. So those are the keys to identify which one of the diagrams, J, K, L, or M, represents nichrome. There you go, guys. Great to have had you till this point. Hopefully you have learnt a lot. Go for more of these topical papers in the site I've indicated, softpapers.co.uk. Download them and attempt as much as you can. And you can reach out for me in my online tuition class, and we can help each other further. Cheers. See you in my next video.